So let's have a look at the task here. We have a network with two routers, branch A and branch B, and on each branch there are two networks, LAN A1, A2, LAN B1 and B2. And we have some kind of remote server, central.pka. And we need to do some IP subnetting and configuration. So we have a partially filled addressing table here that misses a lot of entries, and I guess we will fill that in. As a network technician familiar with blah blah blah, you are now ready to take an existing infrastructure and apply your knowledge and skills to finalize configuration. The network administrator has already configured some commands, so something is done and something is yet to be done. Do not erase or modify the configuration. You should complete the Ipv4 and Ipv6 addressing scheme, implement Ipv4 and Ipv6 addressing and verify connectivity. We should configure the initial settings on branch A and B, configure, blah blah. Okay, so let's start with have a look at the missing information. So we need to do some calculations to enter IP addresses, and I suggest when we do this that we start with finding out all information before we do the configuration. So let's have a look at the requirements. This is a task where we should configure stuff, so wait with that one. LAN A1 is using the subnet 122.2016.0/23. Assign the next available subnet to LAN A2 for a maximum of 250 hosts. So we need to find the next subnet after 122.2016.0/23. And a /23 network is twice the size of a /24 network. So we have a subnet that is using 2 times 256 addresses, 512 addresses in the 16 network. So it's quite a big network. And with some binary calculations with paper, you should find out that so this network 172.2016.0/23 goes from 16.0 to 17.255. So the next available subnet should start with 18. 122.20.18.0. So let's do that. We have PCA, next available subnet for A2 should be, let's write that here, 172.20.18.0 should be the next available network. And I will make this something larger, just to make sure that this is our writing. And a maximum of 250 hosts. There is no subnet that contains exactly 250 hosts. However, that is pretty close to 255 or 256 or 254. So this should be a /24 network, because if we use, let's write that, if we use a /25, for example, we would have half the size of that network. So this should only contain 128 minus 2 available hosts. And if we use 23, we will have the same size as the previous network, and this one will contain 512 addresses. So /24 is just enough. It's exactly what we want to have. So 122.2018.0/24. We have LAN B1 here. This is for Ipv6. We will have the next available subnet /24 should be, and this is Ipv6, it would be 2001.db8.fade. And the big question here is what comes after 00FF. 00FF is an hexadecimal number. That means that we have numbers from 0 to F. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So we have 16 different characters in the number on each position in hexadecimal, which means that this is the highest number available and this is the highest number available. That means also that if we want to find the highest, the next number above 00FF, we must add 1 to that. And if we add 1 to 00FF, we will get the number 0100. So in hexadecimal, we can say that 00FF plus 1 equals to 0100. And we can see here, if you add 00FF with 0001, we will get from the right, f plus 1 is 0, with an additional 1 up here, and f plus 0 plus 1, or 1 plus f plus 0 in the next column would be a 0, and we will get a 1 up here instead also. And sorry, that should be in that column, and this will be 1, and this will be a 0. So 00FF plus 1 is 0100 and nothing else. So the next available network is 2001 DB8 FAD1 0100 /24. Sorry, /64 and nothing else. This is the default prefix that we use almost always in IPv6. And let's stick to the standard here. So this is the next available subnet. And let's make sure that we know that this is our writing. Finish documenting the addressing scheme in the addressing table using the following guidelines. Assign the first IP address for LAN A1, A2, B1, B2 to the router interface. So we have the first available interface, so we have the first available address assigned for the routers in each subnet. And let's have a look at the branch A router in the network A1, which is 172.620.16.1 will be the first address. And for G0, which goes to LAN A2, we will have 172.20. LAN A2 would be the 18 network, 172.20.18. So this would be 18.1. And the net mask for the 16 network is 255.254.0. Don't forget the 4 here. Make sure that this is a 4 there and nothing else. While this network is smaller, the 250-ish address range, and 255.255.0. And again, make sure that there's a 5 there, so it's 255. For the LAN B, we have 4 IPv6 on the branch B. So we see here that branch A, which is the upper part of the topology, runs Ipv4 only, and branch B runs Ipv6 only. This is a bit confusing, and it's normally not what you do, but in this case, we do branch A with Ipv4 and branch B with Ipv6. So we look at the Ipv6 for branch B and see what they say here. We had the first address for A1. This is already solved. For Ipv4, assign the last blah blah blah. For Ipv6, assign the 16th Ipv6 address to the PCs. But we should first configure the make sure that we have the router interface addresses for LAN B1 and B2. So we go up here again. We should have the first address for the routers. So on the branch B, LAN B1, we have the address we have over here, 2001 DB8 FAD 00FF. We will have 2001 DB8 FADE.00FF::1, which is the first available address in that subnet. For the next branch, LAN B2, we have 2001.db8.fede. And the next available subnet after 00FF was 1011:/1, which is the first available address. And here we can remove that one if we want to, because they're not needed, and we can write like that as well. It's the same, it doesn't really matter. So we have the addresses for the branch B routers. Let's have a look at the PCs. The PC for IPv4 assign the last IPv4 address to the PCs. The last IPv4 address for the PCs. So PC A1 is in the 172.20.16.0, and the last available address is 254, because 255 is the broadcast address. And that's a mistake. It should be 17 here, because we have a /23. So the range is from 172.20.16.1 to .17.255. And 17.255 is a broadcast address. So the last available address is 17.254. And for PC B2, we have the next available subnet is 172.20.18.254, because this is a /24, a 255.255.0 subnet. So the last address is 18.254. And we have a 255.255.254.0 subnet in the first network there. So let's see what we have more to do. The first address for this IPv6, assign the 16th IPv6 address to the PCs. The 16th address. This is a bit tricky. So the PC B1 is in the IPv6 network 2001.db8.fade.00FF : and the 16th address. So this should actually say the 16th available address, I guess, because I guess that's what they want to have. And the first address is number 1. Or let's do that, 001. This is the first available address. This is the second, this is the third, and so on. And this is the 9th available address in the network. And after 9 comes 000A. This is the 10th available address. This is the 11th available address. This is the 12th available address. The 13th, the 14th, the 15th available address. And we want the 16th available address. That means that we want to write the next address after 000F. And after 000F, with the same addition as we did before, when we looked at the subnets, after 000F comes 0010 in hexadecimal. So this is the solution, and we can remove those if we want to, like that. And for the next subnet for PCB2 should be in the next subnet. We should enter /64 here as well. 2001.db8.fede.0100, which was the next available subnet, and the 16th address in that subnet is the same as on the last row, :10 /64, and we can remove that one. So that's the 16th available address in the subnet PCB2, in the same subnet that G01 in branch B router is. So that's the subnet on this lower network, LAN B2. And the default gateway for the PCs should be the router address. For PC A1, we should use router branch A G00 address as default gateway, 172. 172.16.20.16.1 for the next PCA2, which would have 172.20.18.1 as a default gateway. For the PCB1, we will have, let's copy paste. We will have this address as default gateway, so we copy that one and paste it there. And for PCB2, I have a slash here. I must remove. That's a mistake, like that. And we have this address as the default gateway for the PCB2 router. And I should add /64 here as well. Like this. Okay, so we have all the addressing in place in our documentation. So we have done the documentation first, which is good. We have assigned the addresses. We have the last address for PCs. For IPv6 we have the 16th address, and now we come to configuring. Okay, so let's do that. Okay, so start with branch A. Let's have a look at that one. Here we have the branch A1 router. See what we have had. We have no host name. We have no interface configuration and nothing else. So let's do that. We start with the including the host name, and we will have this one here. Hostname branch A, and we will have a banner. Let's say welcome. It doesn't say what the banner should contain. The important thing with banners is that the first character here is the start character. We can use any as long as we don't use the same character inside of the banner, and we need to use the same character as the last character to tell the router that the banner is done, so we have no more input to do there. Banner and lines. Banner line VT04 and login, and we will have a password Cisco, and we will have enable secret password of the previous exec is class service password encryption to make sure that all passwords are encrypted, like that. And we will, that was the host name, the banner, the lines, and passwords. Use Cisco as the user exec password and class as the privilege exec. That is done, and we can just as well do the same on the other router while we are at it. So we do that so we can save ourselves a little time. Host name branch B, banner welcome, and what did we have more? Line VTY04, and we have a login, and password is Cisco, and we have enable secret class service password encryption. The same commands as in the other router. We'll find out in the end in the when we look at the scoring if we are on the right track or not. So let's continue on router branch A1. So we have the interfaces. Let's configure that. Show IP int brief. The first interface is gig 00. Let's have a look at gig 00 points to this one. This is gig 00, this is gig 01, and this is gig 02. So we'll find our window first. Where did that go? Branch A. Int gig 00, no shot, IP address 172.16.20.16.1, 255.255.254.0, int gig 01, IP address. What I do right now is just copy and pasting or writing what I've already written in the topology in the addressing table. 172.20.18.1 and int, did I do no shot? Yeah, I did. Int gig 0/2 and 172.20.31.254 255.255.252.0. I should write an IP address in front of that. No shot. Okay, so that was the 3 interfaces in branch A. Let's have a look at the branch B. Int gig 0.0 IPv6 address is, can I copy paste here? That would be nice. Paste. No shot. Int gig 0/1 IPv6 address is paste. Int gig 0/2, no shot, and IPv6 address is this one. Like that. Okay, so that was the addressing for branch B and branch A. What should we else do? Some route. The network has already, the administrator has already configured some commands on the routers that we should not remove or modify. Okay. Configure the router's addressing according to documentation. Include an appropriate description for each router. Oops. Okay, let's do that. Branch B. Yeah. Uplink. Int gig 0/0, and we should have a net LAN B1. Int gig 0/1 description LAN B2. Was it that? LAN B2, yeah, great. That was the descriptions for branch B. Let's get back to branch A. Int gig 0/0 description LAN A1, int gig 0/1 description LAN A2 gig 0/2 description uplink or whatever. So we have the descriptions. Configure routers according to, include an appropriate description for each router interface. Branch B uses FE80::B as a link local address. So we must do that. Let's go to branch B and use the let's see how the configuration looks like right now before we do that. So we have our IPv6 unicast routing is enabled, which makes sure that we have routing for IPv6, which is not enabled by default, so that's good. We have IPv6 address. IPv6 RIP is running. That's cool. I have forgot to do no shot on gig 0/1. Int gig 0/1, no shot, and I must look at the interfaces again. Show run. So we have an IP address of IPv6 here, and we have a no shot, and we have an IPv6 address here, and it's running some kind of RIP for IPv6, and we need to have the link local addresses. I assume that we must have link local addresses on all interfaces in gig 0/0. IPv6 address FE80 : what did it say? B/64, and we add F8 link local. No prefix here. So FE80 : B as link local. And since that FE80 addresses are the link local addresses are not routable, we can use the same link local address on all interfaces in this router. And since it does not say that we should do that on a specific interface, we do that on all three interfaces. And there are no link local addresses added already in any interface. In gig 0/1, we add that one. And it might seem a bit confusing that we use the same IPv6 address on three different interfaces in the same router. But trust me, that's the way it should be. And since the FE80 addresses are local to the link local, they're not routed, and they only have a local unique significance. So we can reuse the same address on all three links, as long as no one else on each link, on each subnet, is not using the same link local address. And no one else, I assume, is using FE80 on LAN B1. No one else is using FE80 : B on LAN B2, and no, not on the link to the central as well. So I guess, if I am allowed to do guesses, that we have done the configuration part here. Configure PCs with addressing. Should we do that as well? We need to configure the PCs. So we do that. Let's have a look at them. The config for the PCs is not allowed to be accessed. We use desktop and IP configuration, and we are on PC A1 now. Let's have a look at our configuration table. We do not need to think anymore because we already have everything in the documentation, so that's good. PC A1 should run IPv4 only, and the address is 172.20.17.254, and the net mask is 255.254.0. Default gateway would be 172.20.16.1. And DNS, it says something about DNS here. The DNS server address for IPv4 on IPv6 is shown in the topology. So we should use 172.20.32.10 as DNS. Let me see if I can find my window here. 172.20.32.10. 172.20.32.10. And for IPv6 we don't care because it is not being used here. PC A2, desktop IP configuration, and we have a look at the documentation. 172.20.18.254, 255, 255, 255.0, and default gateway must be 172.20.18.1. And the DNS server, same as the previous one, 172.20.32.10. Okay. For IPv6, for PCB1, we don't care about IPv4. We go to IPv6 and add the IP address for PCB1, which is this one. And I guess that we should write 64 over here. Link local address can be stay the way it is, and the IPv6 gateway is this one. And the IPv6 DNS server is That's a long IP address. 2001:db8:FAD1:1000:10. Let's copy that one, so we don't have to add that manually once again. That was PCB1. Okay, PCB2. Let's go to that one and go to the configuration, and we add the DNS server first because we already had it in the copy paste buffer. The address for PCB2 should be this one, and /64, and the default gateway we can do like this, ::1 :100::1. Okay, great. So now we have done a lot of configuration. I guess we are done. Configure the router's addresses according to configure PC addressing, verify connectivity between Ipv4 PCs and between the Ipv6 PCs. This is a bit interesting because now we have done a lot of configuration, and it's time for us to see if we have done right or not. Connectivity between the Ipv4 machines is being done by doing a ping from PC A1 to PC A2. So we have the here we do a ping 172.20.18.254. And it does not work. Yeah, it did. It just took a while. I guess it was the ARP that need to fall in place in the PC first. So we can ping between the PCs for Ipv4. We can, just to make sure that we can do it the other way around, but we should, because ping is in both directions. 172.20.17.254 from PC A2 to PC A1 to 17.254. Great. So we have connectivity between those two PCs in the LAN A. And we do the same here for Ipv6. So we are on PCB1, which is this address, and we do a ping 2001 db8 FADE:100::10, and we get a ping. So from PCB1 we can ping PCB2, and just to make sure that there's nothing strange going on, we do the other way around. We do a ping from PCB2 to PCB1, and PCB1 IP address of Ipv6 is 2001 db8:FADE::FF::10. So we can ping there as well. So now I guess we need to ping, need to see if we can ping through the routers and through the environment. What did it say here? Verify connectivity between the PCs and verify connectivity between the PCs. Verify that Ipv4 PCs can access the web page at central.pka. So this involves DNS as well as routing through the topology here. So we must from here run a web browser and enter the URL of, let's see if we can find a web browser, central.pka. Central.pka. Go. Welcome to Central. Great. So that works. Let's do the same on PCA2. Welcome to Central. Great. And from PCB1 we must do we try central v6.pka. It's another URL. Central v6.pka. Welcome to Central. Great. And last thing to test is here, http://central v6.pka. So welcome to Central. So we are done. Verify those can ping IPv6 and these, and verify connectivity, configure PCs. It's always a good thing to finally, when you think you're done, read the tasks again to make sure that you have not missed anything. Configure initial settings. Great. Okay. So I guess we are done here.